Good morning, everyone. My name is Mr. Shoaib Manna, and currently I am working as an assistant professor in the Department of Electrical and Electronics Engineering, ABES Engineering College, Ghaziabad. So, in the previous lecture, I talked about the basics of the control system. So, in that lecture, I discuss about what is the classical control system as well as the advanced control system. Now, in this lecture, I discuss about the open loop control system. So depending on the feedback path, the control system can be classified into two types. One is the open loop control system and another is the closed loop control system. So in the open loop control system, generally that does not depend upon the feedback path. But in case of the closed loop control system, it's depend on the feedback path. So in this lecture, we only discuss about the open loop control system, and in the next lecture, we will discuss about the closed loop control system. So what is open loop control system? So an open loop control system is one in which the output signal is not feedback to the input of the system. So in case of the open loop, there is the no feedback path. So no feedback path means there is no relationship between the input as well as the output. Or we can say the control action is completely independent of the desired output. Now here you can see the basic block diagram of a open loop control system. So here you can see there is one controller and there is one plant or process. So from this block diagram, you can see there is no connection between the input as well as the output, or we can say there is no feedback path. Okay, so if we closely monitor this block diagram, you can see this is the input. So here we generally gives our desired input. Okay, so this is desire, or we can say this is the reference input. So this input we directly go to the controller, and controller arrange in such a way and it force the plant that it should gives the output as per our desired input. Okay, so basically the output of the controller, we can say this is the control signal. So this is the basic block diagram of the closed loop control system. Now, if we consider some gain, means if we consider the input as a RIS and output as a consider as a COS, and controller gain is G1S and plant gain is considered as G2S. So we can say overall gain of the system is nothing but the output by input. So here the output is C0S and the input is RIS. Now, if we consider for only the controller G1, so here for this case, we can say that the output here, this is the output X1S and here is the input RS. So G1 should be written in this way, that X1S divided by R1S. Now, similarly, in case of this portion, we can write G2 equal to output by input. So here is the output C0 and input is X1S. Now, if we multiply both G1 and G2, so here you can see that both X1 will be cut out. And finally, we get C0S by R1S. So C0S by I1S is nothing but the GS. So this block diagram can be represented in this way. So input RS and system is GS and output is C0S. Now coming to the advantage and disadvantage. So from the block diagram, you can easily say that this is the basic, very simple design. We can easily design. It is also the economical, less maintenance is required. And third, there is no stability problem. Now coming to the disadvantage. So main disadvantage of the open loop system is the inaccuracy. And also they are not reliable. And also if we give some input in the system, they does not adapt the variations. Also we have to recalibrate every time to time. So these are the main problem of the open loop system. That's why we go for the closed loop system. Now taking some real-time example that we are using in our daily life. So first one is the washing machine. So washing machine is example of open loop control system. So in general, what we do, initially we give some reset time in the washing machine. Okay, so here you can, this is the timer, or we can say this is the controller. Then what we'll do, that washing or drying process will be start when we just turn on the power. Then what we'll do, it will spraying or discharging the controller. Okay, means it will complete the process and gives the output. But here you can see there is the no feedback path from output to input. So after some preset time, the process will be stopped. So here we can see the machine will stop after a set time, even the desired cleanness of the cloths is not obtained. Okay, so we can say this happens because the machine has no feedback system, that the signals of the control action of the system for the desired output. So we can say this is the basic example of the open loop control system. Now coming to the second one, that is electrical cloth dryer. This is also the open loop system. So here you can see the system stops working after the preset time without considering the state of the cloths. Okay, so cloth may be dry or not dry. The system will switch off after some time. So if we closely look in the block diagram, so here you can see, here we gives the desired time. So this is nothing but the controller timer. Then here we put the electrical energy, and this controller try to turn on the heating element. So this heating element heats the cloths, means we can say this is the process, and the cloths will gives the output that is nothing but the actual dryness. So we can see this is the open loop control system. Then one more example is the burglar alarm. So here you can see this alarm is basically done when the electronic sensor is triggered off, or we can say when some unauthorized person enter to the house, it will send a signal to the receiver. Then this receiver will then activate the alarm. Okay, but the alarm is not turned off after some time. So to off the alarm, we have to go manually and manually stop the alarm. So this is nothing but the open loop system. So if we look into the block diagram here, you can see the initial input we go for the electronic sensor when some unauthorized person enter to the room. Then it receives a signal and generate heat. After that heat, it turn on the alarm. Okay, so output will be the alarm signal. But when the alarm will be stopped, there is no such signal available in this block diagram. So we can say this is the open loop system. Now, one more example, you can see that the automatic traffic lighting control. So basically in the traffic light control, there is three different colors of light. One is the red, one is the yellow, and the green. So each lamp has different fixed time. So the operation of the each lamp does not depends upon the density of the traffic, but only depends upon the fixed time. So we can say the control system which operates on the time basis is nothing but the open loop system. Now coming to other example, here we can see immersion rod. During the winter season, we are generally use the immersion rod. Okay, so there we don't have to give some reference input like how much temperature required. Then we can say one more example is automatic door opening and closing systems, and we can also tell a field control DC motor, etc. These are the reference. Okay, so next class we talk about the closed loop systems and take some example about the closed loop system, how they are working. So closed loop system is the very much important in term of the control system. Okay, thank you.